The last thing we want to do is see how these transformations can affect our basic trig curves. So let's just start with the sine curve. Now let's plot it in. We know it goes between 1 and -1, and I'll mark off my divisions every, 90 degrees, but I'm using radians, so every pi on 2. We know the sine curve starts at the origin, and then it goes up, and then it basically zigzags up and down, backwards and forwards. But of course we don't draw in a zigzag, we draw in a nice smooth curve. So there's y equals sine x. What do we know about it? We know the domain's all real x, there's no breaks in that domain, and the range, as I say, goes in between -1 and 1. But in general, if I want to transform it, all the different sorts of things I could do to it. I could dilate in the x direction, so I'll put a coefficient there in front of x. I could dilate in the vertical direction, so I'll put a coefficient of a in front of the trig. And of course I could put a horizontal shift on it as well, so I'll just add in the -c there. So that pretty much covers every sort of way we could transform that sine one. Well, the basic transformations anyway. Now, a trig curve has a period. How often until it starts repeating. Now, once I transform it, that's going to be 2 pi divided by b rather than 2 pi, because that b, remember we said the transformation would be x over the factor. Well, because I've written it as bx, the factor is actually 1 on b, so we're pushing it in, if you like, but our period then will also be pushed in 2 pi divided by b. We have an amplitude, and if I was to stretch that one vertically a unit, so my factor's a, then the amplitude will be multiplied by a factor of a. Well, the other thing I like to work out is basically what my divisions are. I probably don't write it down, but what I'm going to mark off on my x-axis. And I know that in this sine curve, pretty much those key features, those boundary values, I'm going to divide by 4, so I know how to mark off. Phase is a term that sometimes people use. Phase is basically the shift of the curve. But you've got to be careful. It's not C. Remember, it's when it's grouped with the x. So if I was to factorise this so it's grouped with the x, it would actually be C over b. So the shift would be C divided by b. Oh, it is of course an odd function, so we know it satisfies odd function rule of sine of negative x would be the negative of sine of x. Alright, well let's draw this one then. So y equals 5 sine 9x minus pi on 2. So it's got a bit of everything happening here. Let's try and dissect what we've got. First thing I'll work out is the period, 2 pi on 9, that's how often it's going to repeat. Amplitude, it's now going to go between 5 and -5. I'll mark off my divisions every pi on 18, so 2 pi on 9 divided by 4. And I also know I've got a shift happening on this one, but it's not going to be pi on 2, it'll be pi on 18, so the pi on 2 divided by 9. Let's draw it. I now know it's going between 5 and -5. I'm going to mark off every pi on 18, although I'm only labelling every second one, so pi on 9, 2 pi on 9, negative pi on 9 in the other direction. Now, normally I would start at the origin, but we're shifting this one pi on 18 to the right. So I will start over here at pi on 18. But then I still know the pattern, that's not changing. So I'll go up to the amplitude, and then it'll zigzag backwards and forwards, and if I complete the curve we end up something like that. So there's my new sine curve. Okay, well what about cosine? I won't draw the original one, but it would transform in a similar way to the sine curve, so I'll write it as a cos bx minus c. The period will be 2 pi on b, same as sine, because remember sine and cosine are complementary ratios, they're basically the same curve, just one is shifted. The amplitude will still be a, divisions I'll still do the same, period divided by 4, the phase will still be c on b. It's an even function of course, so this time cos of negative x will be cos of x if I wanted to use that rule. Let's do this. -4 cos x on 8 plus pi and all of that plus 2. So what's happening here? The period will be 16 pi. The amplitude is 4. Remember, the amplitude's not -4. The amplitude's always a positive amount. I'll mark off my divisions every 4 pi. Now we've got a couple of shifts happening here. We have got the phase happening, so it'll go 8 pi, be to the left this one, but we're also going to go 2 up But on top of that, the negative out the front tells me this one's upside down. We've flipped it as well. Let's try and draw this one. The first thing I'm going to do, and you'll notice it's a dotted line, not a solid line, but I've just drawn in the line y equals 2, because my original curve would be winding along the x-axis, but this one's shifted up 2. So it's handy for me because I want to mark in those key points. So if I just draw that dotted line there, I know that that's where I'm going to draw those key points for this one. It means I'm going, the amplitude is 4, so I'll be going up to 6, down to -2. And let's mark off our divisions. I still mark them off on the x-axis, even though I'll end up plotting on that horizontal line. Cosine. Okay, where does cosine start? It normally starts up at the amplitude. But this one has been shifted 8 pi to the left and 2 up. So I'll be starting at 6, except this one is also upside down. So I'm going to start at the bottom of the curve rather than at the top of the curve. So the first point I will plot in will be down here at -8 pi and -2. We then go to the axis, so I'll plot on that vertical line, but then we'll zigzag up and down, and there's our curve. There's our cosine curve. Alright, let's do a tangent curve. Same sort of structure there, a tan bx minus c, but remember the period of the tan function was not 2 pi, it was pi. So therefore the period of our transformed one will be pi divided by b, not 2 pi divided by b. We don't worry about amplitude for a tan curve because it goes up to infinity and down to -infinity. It doesn't really have an amplitude. The divisions, this time I'm only going to mark off period divided by 2. Because the period is half of that, there's really only 2 key spots that we're going to plot. So I'll mark off the period divided by 2 for a tan curve. The phase is still the same. Okay. Oh, it's an odd function. So tan of -x is equal to the -tan of x. Y equals e tan pi x minus 2 pi. What have we done to this one? The period is just 1, pi divided by pi. So therefore I'm going to mark off my divisions every half. And this one's been shifted 2 to the right. There's basically, I don't have to worry about marking on the y-axis. So really, the fact that I put e there is kind of irrelevant for a tan curve. Unless I suppose there was going to be more than one curve on the same graph, and then I might need to have some scale on the y-axis. But for this I don't really need a scale on the y-axis. But I'll mark off my divisions, and they're every they're every half. So every second one will be a unit. Okay, tan, what happens there? Normally with a tan curve we start at the origin. This one has been shifted 2 to the right. So I'm going to start over here. The pattern with the tan curve goes x-intercept, asymptote, x-intercept, asymptote. So let's put that pattern in. There's an asymptote after it, but then going the other way, I'll go asymptote, x-intercept, and so on. And then we'll put in our tan curve, and that'll get repeated between every asymptote. So there's a graph of e tan pi x minus 2 pi. This question a couple of years ago, they were presented with this graph and simply told, well look, it's y equals k sine ax. There's been some sort of transformation to the sine curve. But what would the values of k and a be for this curve? So we have a look at our curve, and what can we see? We can see that the amplitude now is 4 instead of 1. Well, that tells me what k is. K is 4. That one's pretty straightforward. A, we have to be careful with. So A, what can I tell here? Well, I know the period is 6 pi. And remember, period would be 2 pi over the coefficient of x. So 2 pi over A would be 6 pi. Alright, now I can work out A quite quickly. A would be just 1/3 for this curve. There's my final answer. Okay, so 3J is transforming our trig curves.